So example 2, page 655. One of the things that you have to do in a question, okay, first of all, for question A isn't the best question. I'm going to do a question 8.5 right after. Okay? Question 8 gives you two options for solving this. You know what cos of pi over 4 is from your pi plate. So if cos of pi over 4 is root 2 over 2, then cos squared of pi over 4 would be root 2 over 2 squared. And sine of pi over 4 is root 2 over 2. And so sine squared of pi over 4 is root 2 over 2 squared. I hope you can see that those are both the same. The answer to this one is 0. Okay? So we didn't need to use any identities to figure this out because it was on our pi plate. This is actually a textbook making a bit of a mistake in this question because I think this is the best way to solve it. But in question 8.5, which I'm just inventing right now, halfway between A and B, we're going to do cos squared of pi over 8 minus sine squared of pi over 8. And we do a quick look on our pi plate, and uh-oh, we don't have pi over 8 on our pi plate. So this is where you'd say, do we have a formula that matches this? And if we look on our formula sheet, I don't think that got picked up. It's gonna be okay. If we look at our formula sheet, the cos squared something minus sine squared something shows up as a cos 2 alpha formula. So on our formula sheet, we have this. Cos 2 alpha is cos squared alpha minus sine squared alpha. And that's what we have here when we see that the pi over 8 is our alpha. So we have to have our formulas somewhat memorized to be able to recognize that. Then I can change this to cos of 2 times alpha pi over 8. And 2 times pi over 8 reduces to 2 pi over 8, which is just pi over 4, and now I can evaluate it to be root 2 over 2. So even though pi over 8 wasn't on my pi plate, I can still figure this out. B, we have, here I'll scroll up so we can see it. How close does it match up to a formula? Almost, but not quite. Can you see that you have this formula on your formula sheet? Use that formula on your formula sheet. How close does this come to matching up? Very close, except the bottom is bad. So what do we do to the bottom? Okay, again, I don't think they chose good values, because you could figure this out. Tan of pi over 6 is root 3 over 3. You could just figure this out directly. But I want to show you that on the bottom, you could factor out a negative 1, and then the bottom matches up to the formula. Something about fractions. If I have a negative on the bottom of a fraction, or a negative on the top of a fraction, are you okay that all of these mean the same thing with a negative? You could have a negative on the top of your fraction, it'd be the same as having a negative on the bottom of your fraction, or you could have a negative in front of your fraction. So, I'm going to put the negative in front of the whole fraction because then what's inside matches up with my formula completely, And so I can change this to tan of 2 alpha, which is pi over 6, 2 times pi over 6. And 2 times pi over 6 is pi over 3. Tan of pi over 3 is root 3. So our final answer to this would just be negative root 3. Okay, circles, questions 4, 5, and 6. We've got lots of work to do today. All right. And let's turn to example 3.
Just back